Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem number 16. Okay, fluid mechanics, problem number 16. As usual, we first come towards statement. What must be the contact area? Okay, we have to determine area A. Okay, what must be the contact area between a suction cup completely evacuated and a ceiling if the cup is to support the weight of an 80 kilogram student? Okay, what we have to determine? We have to determine area A. Within bracket it is given that completely evacuated. Completely evacuated, this specifies our problem that area is to be determined in connection with pressure. Okay, and dear students, we know that pressure is defined as force per unit area. Okay, so F equal to pressure P equal to F over A. In place of F we will take mg. Here only m is given 80 kilogram and g is constant. We know that acceleration due to gravity has value 9.8 meter per second square. Moreover, in the expression pressure equal to force over area, here we will take value of P as constant from the table of conversion factors of pressure. Okay, we will take a standard atmospheric pressure. Okay, so in the expression pressure equal to force over area, pressure P will become equal to mg over A. Okay, here G and P both will be assumed as constant, and hence out of 4 quantities, 3 quantities will appear in the expression and we will be able to find out the force value quite easily. Okay, so now we come towards the solution. Okay, we start the solution in the same way as our previous problems of this course. Okay, we know that the pressure P in a fluid is the force per unit area exerted by the fluid on a surface, that is P equal to F over A. This is equation number 1. Okay, we have previously described several times that in place of this sign of equality we can also use 3 horizontally parallel lines. Okay, even then this definition will not be affected and it will have the same effect. Okay, in that way it will be read as pressure is defined as F over A. Okay, here it is read as pressure is equal to force over A. Okay, so equality and 3 horizontally parallel lines are almost equivalent and convey the same sense. Okay, in the SI system, pressure has units of newtons per square meter, that is capital N over small m square. Okay, that is Newton per meter square or Newton per square meter. Okay, and 1 Newton per meter square is equal to 1 Pascal, which is abbreviated as PA or denoted by PA. Okay, using F equal to mg. Okay, in this equation in place of F we will use mg. We will take value of P as constant from table of conversion factors of pressures. Okay, and A is to be determined. Here F equal to mg. M is given 80 kilogram and G is 98 meter per second square. Okay, using F equal to mg, where mass is given as 80 kilogram, G is a constant acceleration due to gravity, has value 9.8 meter per second square. Moreover, standard atmospheric pressure has value 1.013 into 10 raised to the power 3 Pascal. Okay, for this value we will show a table below. Okay, rather we will show two tables in this collection. Okay, moreover, 1 Pascal equal to 1 Newton over meter square, as we have described previously. 1 Pascal equal to 1 Newton over meter square is alternatively equal to kilogram per meter second square. Okay, it once again alternatively becomes equal to joule per meter cube. Okay, all these four values are equivalent. Okay, using all these values in equation number 1, we get, in place of P we will use this value 1.013 into 10 raised to the power 5 Pascal. In place of M we will use this value 80 kilogram, and in place of G, M this, G this over A is to be determined. Okay, in the next step we will keep area A on one side. Okay, because it is to be determined, it is to be find out. So area A in the denominator will become in the numerator on the other side of equality. Okay, so area A will become equal to 80 kilogram into 9.8 meter per second square over 1.013 into 10 raised to the power 5. In place of Pascal, we have used this equivalent value. Okay, kilogram per meter second square, kilogram per meter second square. Okay, here dear students, this meter second square is in the denominator of the denominator, so it will be multiplied, it will be assumed as in the upper part of the numerator. Okay, moreover, kilogram will be cancelled out with kilogram, and second square will be cancelled out with second square. Okay, because this second square will appear here on the upper side of the numerator. So second square will be cancelled out with second square. Okay, and our result will appear only in form of meter square. Okay, because we know that area is in two dimension, always in meter square or centimeter square, etc., while volume is in three dimension. Okay, meter cube, centimeter cube, etc. Okay, and hence after simplification area will become equal to 0.08 meter square. Okay, so this is our solution of the problem. Okay, area is always two dimension quantity, so it always it is written in terms of square. Okay, meter square, centimeter square, etc. While volume is three dimensional quantity and is written as meter cube. Okay, we have found solution of our problem. Now we will show two tables in order to explain why we have used this value. In place of P we have used this standard value. Okay, our answer is complete to this extent. Now we move further to explain why we have used this value. Okay, this is the table conversion factors, that mean different units of pressure. Okay, here 1 atm is equal to 1.013 into 10 raised to the power 5 Newton per meter square, equal to equivalently equal to 10 raised to the power 5 Pascal, equal to, if we multiply it with 1000, then it will become no, if we multiply it with 100, then it will become 101.3. Okay, and from here 10 raised to the power 2 will be deducted, will be subtracted, and we will be left with 10 raised to the power 3, which is equal to kilo. Okay, that is why this can be written in terms of 101.3 kilopascal. Okay, so this is again, this table again explains a similar picture. Okay, 1 Pascal equal to 1 Newton over meter square. This is in terms of pound per inch square. This in terms of pound per feet square. Okay, this 1 atm equal to 1.013 bar. Okay, so these two tables were just to explain why we have chosen constant value of pressure P. Okay, now we come towards the reference from where we have chosen this problem. Our reference book is Physics for Scientists and Engineers with Modern Physics. Authors are Raymond A. Survey and John W. Jude Jr. Its publisher is Cengage. Its 9th edition, having been published in 2014, has been adopted, and here chapter number 14 under title Fluid Mechanics is our concerned chapter, and this problem is enumerated at serial number 9 of the exercise given at the end of this chapter. Okay, that is exercise number 14.9, and this is the end of our problem. Okay.